is one of two sessions I'm doing today. First one here is called Database Maintenance Essentials. And as you can tell by the name, it's more towards a beginner kind of class or session rather than an advanced session. But I think one of the things...
The power's on mute.
I think one of the things that you'll find out is hopefully even though you may be an experienced DBA, you'll find out a few new things that you didn't know before. And also what we'll do too is, in a couple of occasions, I will show some Redgate tools that are related that might help you become a little more efficient in your database maintenance. So as we go along, feel free to raise your hand and ask questions. We have about an hour. There's also a 30-minute break right after this session. So if there's a lot of questions, I might decide to go ahead and stay here longer myself because of the break. And you can stay here longer if you want to, but if you want to take the break and leave, that's fine too. I'm comfortable with that. So I'll stay as long as you want to until the next session starts up, which is, again, 30 minutes after this one officially ends. So I work for Redgate Software as a Director of DBA Education. I'm a SQL Server MVP for about 10 years. And I'm also, as maybe some of you know, I'm a famous actor, or infamous actor. You know, how many people watched the series we did last year on DBA in space? Some of you did. That was kind of an interesting experience, having a non-actor try to act. It was rather interesting. I'm not sure if it's something I'll ever do again, but something kind of interesting to do once in my life. You know, be in front of a professional film crew and make a fool of yourself. But that's another story. So what we're going to talk about today? Well, we're going to talk about really common stuff. Because one of the things I find out as a DBA, in many ways our job is really boring, isn't it? I mean, if you do your job right and get everything set up right, it's really boring, everyday stuff that you just have to do. And of course, the nice thing to do is try to automate as much as you can. And so what I want to go is talk about these particular areas, managing the MDF and the LDF files. That sounds really boring, but it's really critical stuff to do it right. And same thing, managing indexes, boring, but again, something that's very important. Statistics, looking for corruption. Be sure that you make backups that actually restore it, because a backup's not a backup unless you know you can restore it. And of course, managing maintenance jobs. So I'm going to talk about some best practices and suggestions I have in all these particular areas. Again, since we only have an hour, I can't cover these in great depth, but I'm going to cover what I think some of the high points are. And some of this stuff you probably will know. Yesterday I had some people who came up to me after the session, I did it, and they were experienced DBAs. And they said, well, yeah, I know most of the stuff that you talked about, but you said something I had never heard of before. And he said, that was really cool, I didn't know that, so I'm going to go fix that when I go back to the office. So hopefully maybe some of you who are more experienced DBAs will pick up a few tidbits that you didn't know before. And again, feel free to ask questions. As you see my little disclaimer here, everything I recommend may or may not be appropriate to you. Like everything else in the SQL Server world, it depends, that famous terminology, and it's really true, depends upon your situation. So the stuff I'm recommending generally is, I'd say, applies 99% of the time in most cases, because I chose to choose the really common stuff, not to get the more controversial stuff that would depend more on the situation. So let's go ahead and go from there. First of all, managing your MDF and LDF files. When Microsoft first came out with SQL Server, especially in the 7.0 version, when they actually had their own, they actually wrote their own code. When before that, it was mostly Sybase code, and they just kind of put their name on it. 7.0 was the first really version of the code that they actually wrote themselves. They marketed it in such a way is that basically, oh, this program, you buy this database, you don't have to worry about it. You don't even need a DBA, really. Just stick it in the side of your box, stick your application to it, and it would work and take care of itself. Well, as most of you know, that's not true, and it never has been true. SQL Server is hard to manage properly. It sort of will barely kind of do its work, if it's a really small system, but anything of any size at all, you have to physically go out there and do the work yourself. And you have to be a proactive manager. And I know a lot of novice DBAs still believe in this myth. I mean, it still survives today. So one of my jobs or responsibilities I take on is you can keep knocking down that myth over and over and over again, because a DBA job is very important and very valuable. As you know that, you're all DBAs, right? If you didn't exist, would your company be able to operate? Probably not very well, most likely, because people underestimate the needs and responsibilities of the DBA. And some of them are very basic. And one of those is in managing the MDF and the LDF files proactively. And also by that I mean manually also. So first of all, let's look at MDF files. And here are some things that I recommend. Again, they're just basic best practices. One of the things I emphasize very strongly is that whenever you create a brand new database, and we've all created brand new databases, is to go ahead, when you create it, based on the best knowledge you have at that time, is to pre-size it to a size roughly about a year from now. In other words, try to don't create the database at its default size, which I see people do all the time. And what they do is they let auto-grow kick in, and let it grow and grow and grow and grow and grow. I don't recommend that, and in the next slide I'll tell you why I don't recommend it. So I'm going to save that explanation for a moment. But I think it's very important that you pre-size your databases for a variety of reasons, which I'll talk about. So again, it's impossible to know an exact answer to what that number should be. But based on information that you have as a DBA and of the application, whether it's a third-party app that you bought or it's an application you've written in-house, you should have a general idea what it should be. And you're never going to guess exactly right, but you should make a good guess, the best guess that you can. And of course, when you do that, what criticism I hear from a lot of people says, well, all this space is going to waste. Because they say, I estimate a year from now that database is going to be a terabyte in size. But today, it's only 100 megabyte. And you say, well, you have all that wasted space out there. You're not doing anything with it. Why do that? Well, I don't care. I think it's a great thing. You should be doing that. You should be pre-allocating that space. And then I'll talk more about that in just a moment, a little bit later. What I see people do, especially novice DBAs, is they'll come to a database and they say, oh, there's empty space in it. And what's the first thing that someone will do? Shrink it, because to get rid of the space. Because sometimes maybe it's a legitimate reason. We don't have enough space in our machine. That could be a possibility. But again, my presumption is if I'm going to guesstimate it's going to take a terabyte, guess what, when I order my machine, I'm going to order probably a 2 terabyte or bigger machine because again, I expect future growth. Because sometimes you're stuck in a situation where you can't do that. You're kind of like, here's your hardware, deal with it. But sometimes then again, you can't follow all these recommendations. So this would be obviously ideal recommendations. Yes, obviously your estimate's not going to be accurate. So one of the responsibilities, again, as you as a DBA, is to proactively watch the growth of your data in the database. So when you set that terabyte size, for example, and it starts out roughly at 100 megabyte, you want to watch over time how that's growing. Is it growing what you expect? Is it growing under you expect or way over what you expect? So again, one of your responsibilities is to constantly monitor how much data is actually in this database as it grows. Obviously, if you underestimated it and you find that out by watching it over time, especially if you can graph that information or see trends, and I'm going to show you a little demo how you can do that here shortly, then you say maybe 3 months or 6 months, I'm way off. It needs to be 2 terabytes rather than 1 terabyte. So now I know that. So now today I'm going to manually grow that database from 1 terabyte to 2 terabytes, assuming I have this space, of course. And I'm going to do it way ahead of time. Again, because I want to proactively have it grow. Actually, if I have an auto-grow occur in my database, I consider myself a failure because I didn't do a very good job of predicting what was going to happen. I wasn't paying attention to what was monitoring close enough how fast the data was growing. So that's kind of my challenge is I never ever want to see auto-grow in the MDF. Sometimes in the LDF I'll see them, but that's a little different situation. I'll talk about that in the next couple of slides. And of course, if you overestimate, that's not a big deal. Again, let's say you estimated a terabyte. At the end of the year, it's only 500 gig. You only got halfway there. So what? Now you know roughly how it's growing. Leave that space there. Don't shrink it. Again, shrinking is a bad thing generally. Why is it shrinking a bad thing? Who can tell me? Yeah, you can fragment your files every time you do it, which of course then you can rebuild it to defrag it. But when you do that, what happens to your database? It grows again because it has to make room for growth. And as you start doing that kind of growth, shrinking and growth, it causes physical file fragmentation, which I'm going to talk about in the next slide, which is a performance penalty. So again, don't worry too much about it. Just do your best guess. You're never going to be right, but you need to monitor it and always be ahead of the game. That's my key recommendation. So what are the benefits? The first one, of course, is again, I don't like auto-growths. Auto-growths occur unexpectedly. And when they occur, depending upon whether you have file initialization turned on or off, you may have a point of contention when it's growing. For example, if auto-grow is set in such a way that your database grows 100 meg, or maybe 100 gig, depending on how big it is and how your auto growth settings are. When that growth occurs, you have, of course, a huge resource hit, and basically your server stops because it has to basically lock the database, so nothing happens during that time. And that can be a big deal sometimes it's not a big deal. But the bigger issue actually though is the physical file fragmentation. Because auto growth, every time it kicks in, it grows a little bit more, a little bit more, a little bit more. And depending upon how your disk is configured, the file will break up into pieces. And so instead of having one contiguous file, which you would have if you created ahead of time, like I recommended before, you'll have a part of your database here on a hard drive, part of it here, part of it here, part of it here. Of course, it's kind of imaginary because obviously we have probably an array somewhere and they're going to be scattered all over the place. And if you have non-contiguous files, then what's going to happen is that when SQL Server goes out there to read the data, the heads have to work harder. If the file is contiguous, it can go read the files much easier, especially when you do a table scan. But if you have to go look at this piece and this piece and this piece and this piece, just to gather them all up, it takes a lot of extra work and slows your I/O down. So that's actually the main reason I recommend you pre-size the stuff, is to eliminate the auto growth, which eliminates physical file fragmentation. Because you can fix physical file fragmentation after the fact, but a lot of people don't. I've been in situations where I've literally seen tens of thousands of auto growths occurred on a database. That means tens of thousands of fragments. And then once we've cleaned this up, we've basically shut SQL Server down, the physical file is closed, we run a defragger program of some sort, either one built into SQL Server or a third-party one. It takes a couple hours maybe to make it all contiguous. We turn it back on and look at it, and all of a sudden performance is just way up there. I mean, disk I/O now is much, much faster than it was. It's a significant difference in performance. Because as it's doing, over time, as it's slowing down, you don't really notice the slow down because it kind of occurs slowly. But eventually you will get annoying and you'll figure out, why is my machine so slow? And the reason it's so slow is because you have all this fragmentation going on. And even if you have a SAN, it's going to happen to you. Even if you have SSD drives, it can happen to you. Neither SSD manufacturers or SAN manufacturers would like to admit that, but it will occur on those devices too. Maybe a little less slowly than it would be on a local attached storage, but it's still going to happen to you. Physical file fragmentation is a topic that's not talked often enough because it's one of those secret performance killers that exist that people just aren't aware of, or people kind of poo-poo and say it's not that important. But it is important in many cases. It's 5 fragments, who cares? But if it's tens of thousands of fragments, it's a definite performance hit. So again, you need to regularly monitor your database growth so you can manage it, not let auto growth kick in. LDF files are very similar. Yes, sir, go ahead.
There is the auto shrink option, which I don't see any reason whatsoever to use it to turn it on. And it's still there, and I still see DBAs doing it.
Yeah.
Is there any reason that it's still there? Because it doesn't remove this option?
The good question is, it's talking about the auto growth option, which is the database option, auto shrink option, right? That's built into the database. In each database, you can turn it off or on, but default it is off. That's a good question because as a SQL Server MVP, I've been invited to Microsoft to provide feedback. And one of the things that always comes up is, why don't you remove that? Because it's horrible, it's bad, there's no positives to it whatsoever. And I've never got a good answer. And none of the other MVPs have had good answers. Microsoft is very slow to remove stuff. There's other things they should be removing too, like auto close. There's another feature that actually was designed for SQL Server Express, not any other products, but it's still there. And there's a lot of other things that shouldn't be there. SQL Server can work very efficiently and very quickly if you do it right. But again, SQL Server allows you to make lots of stupid mistakes too, like make duplicate indexes. You can make 999 exact same indexes if you want to. It will let you do it, even know how dumb that is. We'll talk more about indexing a little bit later. Yeah, I don't know why the answer is it's just very slow to change. They'd like to keep things backward compatible as possible, but again, in that particular case, it's not really an issue, so I don't know why they haven't dropped it. It doesn't make any sense. Managing the LDF files is also very similar. I think you should also pre-size those, but it's more difficult because on an MDF, you can get a good idea, a good feel for the amount of data, at least better. LDF's really hard to figure out because there's many factors come into play in estimating LDF. First of all, what recovery model are you using? How busy is your database? How long are transactions run? How often do your transaction log backups? There's all kinds of things at play, and it's very, very hard to guess. And I pretty much got to the point where I know I'm going to guess wrong. But I have to guess something. But I don't want to leave it at the starting default size and let it auto-grow, and literally get tens of thousands of them also. So I do make a guess, but what I'll do here is I'll know I'm going to be wrong, and I'm going to adjust it much more quickly. So I'll come up with a basic number of basically a starting point of roughly 5 to 10% of my largest size. So for example, if it's a terabyte size, I may make it anywhere from well, my example, there's a 500 megabyte size. I guess 25 to 50 gigabyte is roughly as my log file size. But again, I may be completely off on that because I don't know, because so many factors go into it. Then though, what I do is when I go into production, I very quickly watch that and see what's going on, because right away you're going to see activity, and you probably within hours, if not days, you'll know how wrong you were. Because again, that activity occurs very quickly. And at that point, I'm going to be watching it, monitoring it, see how full it is, and then I'm going to either see one of two things. One, I've underestimated it, and auto-growth starts kicking in before I even know it. Okay? Now, at that point, I'm not going to feel guilty about auto-grow like I feel auto-grow on MDS, because I know this is a tough one to do. And if I see, because I'm watching it and I do miss it and some auto-grows occur, oh, I know it needs to grow. And so I'll go ahead and grow it manually a little bigger, and then to watch it. At some point, it should kind of level itself out, more or less. Usually log files generally at some point kind of come to like an average typically. Of course, the actual data will grow in and out all the time, but that maximum size should pretty much average out at some point. But if you incorrectly monitor, guess it, again, it's not a big problem. You couldn't change it, but again, you need to monitor it. We can monitor it with various tools. I'm going to demo that in just a moment. There's one issue, though, I want to briefly mention also about LDF files, is that sometimes, how many people in a situation where an LDF file all of a sudden just grows crazy big, all wild and stuff? Well, that occurs. That's one of the weird things. You won't see that in an MDF file, but you'll see that in an LDF file occasionally. And there's a variety of causes for that. One, maybe your transaction logs aren't being made like they should be. Maybe you set up a job to have them run every hour, but the job fails, and all of a sudden now it grows and grows and grows because it can't truncate itself because it's not backed up. Or because someone wrote some kind of code that has a really long running transaction which prevents the log from being truncated, or some kind of mistake or problem. So if you have that kind of situation, the first thing you need to do is figure out what's causing a problem and fix it. And if you know you found the problem, you fixed it, and if now you have this huge file but you don't need it anymore, then I would feel comfortable shrinking that file. You don't have to worry about file fragmentation in a log file because there's no indexes to be fragmented. That's not a problem, so you can shrink it. But what you don't want to do is get in a situation where it grows really big, and because of a problem, then you shrink it, and because you didn't solve the problem, it grows back again and shrink it big and shrink it over and over again, which will cause physical file fragmentation, really bad in your system. So if you know you found the problem, shrink it. If you don't know what the problem is, don't shrink it, because again, it's going to keep on occurring over and over again. And maybe there's a legitimate reason why it should be big. Maybe because of the nature of your application, it just has to be big. I've seen that. We don't have any choice, but you just have to live with it. And once you've learned the characteristics of your system, then that will make sense for you. The benefits of this I've already pretty much mentioned, the pre-sizing, but the last one is different in LDF files than MDF files. LDF files have something called virtual log files. How many people have heard the concept of a virtual log file? Oh, about a third of you. That's pretty good. Because lots of times people don't even know what that is. Every time you grow the transaction log, it will create 4 or more what are called virtual log files, depending upon how big the growth actually occurs. A virtual log file is something you can't see, really. It's something used internally by the log file in order to keep track of basically where it's at and know where it can truncate at. It's something we don't normally have to really worry about, except if we have too many of them. Every time you have an auto growth, at a minimum, there's going to be 4 virtual log files created. It could be up to 16, depending upon how big the growth is, but minimum 4. Let's say you have 10,000 auto grows. Now you have 40,000 virtual log files. Does that sound like a number that's reasonable? What do you think might happen? You can have really bad performance in your transaction log. The ideal number of virtual log files in a transaction log is less than 100. Now, it can float between 100 and 200, maybe depending upon how big it is. But if you get way over 200, you have too many. I have written a presentation. You can go to my website, which is bradmcgehee.com, and find a presentation I've written called Inside the Transaction Log, and it tells you the architecture, how it works, how VLFs work, and it will give you some code that you can run to find out how many virtual log files you have. And if you run that code, you'll be amazed sometimes. Wow, I didn't know I had 85,000 virtual log files in my transaction log. And maybe that's why my performance in my systems are really slow, because the transaction log is the most critical performance part of your system. Did you know that? It's because no transaction can complete until it's written to the transaction log and it gets a message back saying, I wrote successfully. Then that transaction can finish and then go back to the application and so on. And all that time, of course, locks are being held or whatever. And the more transaction logs, virtual log files you have, the longer it has to deal with it, and it takes longer and longer and longer to deal with it. And so generally what happens if you have lots of VLFs, then you solve the problem is basically you need to shrink it back to almost zero and then grow it proactively in a certain manner, usually 512 meg at a time is kind of the recommendation. But I talk about it in my other presentation that I do. It's an hour-and-a-half presentation, so obviously I can't do that here today, but I want to refer you to that particular one. Also, if you've read any information from the SQL Skills website from Paul Rando and Kimberly Tripp, I don't know if you're familiar with that website or not. Kimberly has a bunch of blog posts that talk also about the same topic. So it'll be another area to research it if you want to find out about it. But one of the things you should do when you go back to work next week, find out how many VLFs you have in your log files. If you have more than 200, you need to start thinking about fixing that problem. It's not a big deal to fix it. When you can shrink it and grow it manually, it's not a big deal. And I explained it in my presentation, and also Kimberly explains in her blog how to do it. It's not very difficult. But a lot of people don't know this because they would use auto growth all the time, and you can literally tens of thousands, 50, 60, how many, 100,000 virtual log files I've seen in big systems, and this really slows down a SQL Server, because SQL Server has to keep track of all these, right? What's easier to keep track of 30 or 40 virtual log files or 50 or 60,000 of them? Obviously, there's a difference there in keeping track and performance and overhead. So that's why I like to manually manage my MDS, my LDS. I'm going to do a little quick demo here. How many people are familiar with the product that we sell called a SQL Monitor? Some of you use that? Well, SQL Monitor can help you in some of this stuff, especially the monitoring. I just want to point out a couple things about it that you might find useful. This is what SQL Monitor looks like. Again, this is, for those who are not familiar with it, it's just a web-based monitoring tool that basically, for a certain degree, basically just watches a certain predefined set of areas and can create alerts for you. It also monitors certain performance monitor counters and also can track that and store it and do trend line analysis for you. Some basic stuff you just look at. When you go to the main screen, for example, the server level, you can go down and look at things like your drives. This is obviously a demo machine on a regular server, so it looks kind of maybe the odds, but you can see how much free space that you have. Here's another question for you. How much free space should you have in a hard drive before you might have performance issues? Anybody have an idea? 100%? Okay, 25, that's not a bad number. Yeah, my rule of thumb is always have a minimum of at least 20% of free space. More is even better, but 20%. Do you know why that is? What happens when a hard drive fills up? What? Not necessarily. I have more to do with a memory issue. But I mean, paging can contribute to it. Well, one thing that you may not be aware of is the NTFS file system has something that you probably don't know it has because it hides it and you can't see it, but it's there. It has a transaction log. SQL Server has a transaction log. We can see it, we can manage it. NTFS has a transaction log also. And the reason for that is, again, the same reason we have transaction logs in SQL Server. If SQL Server goes down hard, well, we can roll forward or roll back transactions because they're in a transaction log, right? Same thing with files that are open in Windows. There's hundreds of files that are open in Windows. If the server to go down hard and there were no transaction log, when you bring it back up, what would happen? It'd be a whole bunch of corrupted files. Anybody here ever used Novell 3.x or earlier? A few of you? What happened when 3x went down hard? It was dead. The server was dead because all the files were corrupt. And so you never want to bring a 3x server down improperly. But sometimes power went out and didn't have any battery backup. That's what happened. So when Microsoft came up with NTFS and to compete against Novell, which was 3x, was very popular Novell. I mean, it was big networking for a long time and really outshined Microsoft. But Microsoft came out with NTFS for their Windows 3.5, I think, but the first version they really came out with seriously. NTFS had this transaction log built in. Well, transaction log takes space. So if you start running out of space, the transaction log gets smaller and smaller and smaller, and it makes it much more difficult for SQL Server to keep track of all logging and everything, and it causes I/O to slow down quite a bit. So once you get less than 20% of free space, performance I/O on your system, whatever it is going to start slowing down imperceptibly, but it will slow down, slow down. And of course, you also risk the case of running out of memory in the first place. Or if you're running into defragmentation programs, they won't even run if you don't have empty space, because it takes empty space for it to rebuild the files as it defrags them. So there's lots of reasons. So a minimum of 20%. So that's one of the things I would suggest you monitor. And so again, there's different ways of doing this. This is one way quickly I can see how much space is used in my drives. Another thing I can do down also on a SQL monitor is to go down to specific database, for example here. And I can see what's going on with my database size, log space used, here 2.4%, which is not very much. And I can also come down here and find out more information about the current situation of my physical files. This is stuff you can find in Management Studio also. There's also some alerts. Another alert that which is kind of handy is the disusage alert. I'm actually not going to look at it here. This is actually where the alerts occur. I prefer to show you what a configuration is because it's a little easier to see what I'm talking about. I'm going to go over to alert settings, and I'm going to go over to disk space. And this is one alerts that are built into it that, again, let you determine whether you have a problem. These are settings that have been set up. You can change them any way you want to. And as you can see here, you can get an alert if you get up to 70% full, or if it's 80%, which is my maximum, you get a big warning. You say, you're getting close, you need to do something about it right away. So it's a nice way to automate it. Because when I started out as a DBA many, many years ago, we didn't have any automated tools. So the first thing I did in the morning is sat down and I logged into every computer separately. And first of all, I checked the hard disk space. How much space do I have left on my machine? Because I didn't have any tools to monitor it. And I don't know what happened last night. And then I went and said, did all my jobs run successfully? And you know, how much data is in my databases? I did that manually every day. It was really boring. But that's the only way to do it in the old days. And I wasn't really good at scripting back then. I could have written some scripts and done some of that for me and automated, but I didn't. I did it all manually for a long time. So this is another way of doing that kind of stuff. Another tool that's also built in, which is kind of handy, which is under the Analysis tab, which are basically performance monitor counters that collects data regularly and lets you graph it. We have one that's disk used. See if you want to see disk used over a period of time. This is the last. You can see different time ranges you can pick. For example, 30 days would be handy to find out what kind of trend is occurring, how your database is growing or your logs growing or something like that. Fortunately, I don't have 30 days worth of data to show you because it's a test machine. It's always on, off, and on and off all the time, so the data is not very accurate. But you can kind of get a feel for what's going on in the real world. This is on all the time. With your servers are being on all the time, you actually see things increasing over time and get a trend line. There's also some other ones you can look at. Under databases, total size, data size, log space used. And those are ones I actually use a lot because, again, it allows me to create trends. This stuff, it can be stored for at least 30 days, if not longer. And actually, some of these I set for longer, so say stored today for 90 days. That way, over time, I can look at my database and see how fast they're growing and literally see a graph and know what's going on. I can do some linear regression or just guesstimation and say where I'm going to be at in the future based on the current trends. So it makes your life a whole lot easier rather than just check it manually every day and write down a piece of paper or maybe a spreadsheet and try to figure out the hard way. This will automate it and make your life a little bit easier. Indexing, new topic. Let me drink some water. Indexing is also another very critical area that lots of times is ignored until you really have to do it. I'm one of these people who are proactive on indexing. I don't wait till there's a problem. I prevent the problems in the first place. And the reason for this is because your database changes over time in two ways. One, the actual physical data itself changes. The skew of it, the data, the quantity of the data in the tables changes. Also, how you gather data from it, how you query it, different reports that you might write will vary over time. And that will affect your indexing needs. And it often require new indexes, modified indexes, or even getting rid of old indexes no longer used. So one of the things you need to proactively do is go out there and do this kind of work. Here's some kind of things that I do. This is probably the most obvious one is index tuning, basically looking for missing indexes. Now, in the perfect world, if I have lots of time, I prefer to manually tune my indexes, one at a time. But that can be very time consuming, especially if you have a database with 1,500, 2,000, 3,000 indexes, which I often have. You don't have the time basically to manually tune individual indexes, even though occasionally you might have to because, again, you have special cases. So as I use the built-in tool, most of you probably done it, is the database tuning wizard. How many people have used that tool? Less than I thought. You should all be using that tool periodically. Basically, what you have to do, for those who are not familiar using the database tuning advisor, is you have to take a profile or trace over a representative period of time, which collects all the queries that you've done, and then run that against the DTA. The DTA will be able to analyze and determine what indexes are missing using a pretty sophisticated formula. It does a pretty good job recommending indexes. And it won't recommend indexes for everything because it will look at how often the query runs, and again, whether the index is beneficial or not. It will test things out, make all kinds of recommendations. And usually the results you get from it are pretty good. Because I never take things literally when it comes back with the response and says, oh, this is what I recommend. I will eyeball it and say, well, this makes sense. And if it makes sense, yes, I'll go ahead and add it. Sometimes I'll look at it and say, that doesn't really sound right. And I'll research it and maybe I'm wrong and it doesn't work out. Or maybe it's not appropriate. So you need to use a little bit of your experience. But it's still better than nothing. If you don't have the experience to be able to evaluate it, then take its recommendations because it's going to be better than no recommendations at all. Yes, sir?
Just a word of advice, don't use the names that the DTA gives.
Yeah.
They're very difficult to follow.
Yeah, the DTA comes up with obscure names. So what you can do is you can have it basically display the script to create the indexes. And you can go in there and create your own names that are more appropriate. Otherwise, again, they don't make any sense. Very good point. I'm not sure why they don't do a little better job in doing that, but they could. You think even just taking the name of the column or something like that, or the table name or something, make more sense than the random numbers they kind of come up with. So at the minimum, you need to be doing that. Now, some of you may be familiar with this DMDB, Missing Index Details DMV. How many people have seen that? Okay, way more people then raise their hand on the DTA. That's sad. The reason for that, this is really crappy. Now, why is that? Now, the Microsoft Books Online won't tell you in there, oh, this is a crappy DMV. It will tell you all kinds of things about why you should use it. Why is it crappy? That's because the information that's stored in here is actually generated by the query optimizer. So every time a query goes to the query optimizer and becomes optimized and creates an execution plan, query optimizer has the ability to look at that query and say, I could have actually created a better execution plan if I had a better index. And so it takes that information, the index it thinks it needs, and just dumps it into there. But the recommendation is based on one index running one time. And then next time runs a similar query, it might recommend an index that's almost identical to the first one with one minor change. Or sometimes it will recommend an index that already exists. It's that stupid. And so if you were to follow and create every index it recommended, you would end up with a lot of duplicate and redundant indexes that you don't need. That will actually cause you problems. Also, it can provide you good information too. But to use this, you have to really, really understand your data, understand what's going on, because you don't know what query this is associated with. It didn't tell you what it is. You just have to kind of guess. And I've done that. I've actually tried to use this tool, find out all the recommendations, and I went through and looked at every recommendation. I compared it to the real world that already existed. And first of all these duplicate indexes already said it exists. I don't know why it came up, why it does that, but so you mark them off the list. Then you go back and compare them to what's already existing and say, well, this is kind of redundant. I mean, yeah, it added one more column. So rather than create a new index, what I really need to do is modify another one, make it included index kind of thing. So in other words, you have to do all the manual work to make it work right. So I recommend you don't use that. Now back to one example where I mentioned where the query optimizer will recommend indexes, and you probably see that when you create an execution plan sometimes. Very top in green, it will say recommended index will increase your performance so many %. That's the information that goes over here. Now when I'm actually doing that, if I'm analyzing a query and I get that kind of recommendation, that's better though than getting it raw here. That's because I know what query I'm talking about. Here I don't know what query it's referring to. So now I know what query it's talking about. I can see the index. So then what I will do is I will look at all the indexes that exist on that table, all the indexes that are being used by that query, and now I can make a legitimate choice in my head. Hey, maybe that actually is a good index because I have enough information to make a good decision. And I'll oftentimes make that recommendation and actually use that recommendation. Or I may not, but again, I have more information to know. Well, here I don't have any reference. Know what queries are being used. I don't know if just one query ran once. It's an ad hoc query someone run one time, will never run again. And why would I want to add an index to a table with 10 million rows for one ad hoc query run one time? I don't know that. And that's the kind of information that you'll get here if you follow it literally. That's why the DTA is a much better tool, because it will analyze all the queries over a period of time. And if it finds just one errant query that might need an index, it's smart enough to know, well, that's not worth the effort because indexes require maintenance. And every time you add a new index, there's more overhead associated with maintaining all those indexes.
Right?
Yes?
Regarding the DTA, it's also very important to stress the time frame is very important.
Yes.
I've seen people take workloads that are not representative of all the activity on server, and then the DTA might, for example, recommend to drop an index.
Yes.
Do that, and it's very, very dangerous.
Exactly. A good point. The DTA you need to take data over a representative period of time. So what I usually do is find out what that is. Usually as a DBA, you can figure out what that is. It's a prime time of day. And I usually run it for a number of hours, generally. And also the option in terms about dropping it, that's like an option you can choose. I always remove that option. Because again, you're right, if it doesn't run, it will recommend removing it. And I'm going to talk about removing indexes, actually unused ones here shortly, but in that short time period, there's not enough information really to make a good judgment about whether to drop one, so I deselect that option. Now the unused indexes, actually, we're just talking about, I do like to review and look for unused indexes. DTA, again, is not the best tool for that, but in this case, there's actually a DMV that I like, the DM DB index UC stats. Now this is a little tricky though. This particular DMV resets itself every time SQL Server is restarted. So if you restart SQL Server and you go to this DMV, it would literally show every index not being used. Now obviously that's not true because it's going to be used eventually. So after at least a week being up, if not a month being up, then if you run this particular DMV, it will show you those indexes that have never been used for that period of time. So, yes, sir?
Are DMV metadata tables? I'm an Oracle person. So.
DMVs are a variety of different tools that basically allow you to inquire about internal activity of SQL Server. For example, this particular DMV allows you to determine whether or not indexes are being used. There are literally hundreds of DMVs. It's basically a way to look at the internals, live internals of a system. And they're all over the place in what they do. So this one is a great one if you let your system up long enough. If you're constantly bouncing your system, this is not going to be a very effective tool because it's not very accurate. Because my personal opinion is I never bounce a SQL Server, only except maybe quarterly when I do my patches. So my systems are up at least 3 months, if not longer. And when they're up that long, then using this DMV is very useful because, again, if an index has not been used in 3 months or 4 months or 5 months or 6 months that you serve is up, you know that index is never going to be used. Of course, you can still look at it and say, why is it there? And oftentimes what you find out, especially if you've got a third-party vendor application that was shipped to you, or you have an application written internally in-house by people who aren't really DBAs, and some people get kind of index crazy, and they add indexes all over the place because they think they might need them. You'll find out the first time you run this, there's a whole bunch of them you don't need, either from the vendor or from the people who wrote the initial application. They're just never used because they're just guesses in the first place. It's actually, when I design a database, I only add a few indexes. Basically, indexes, obviously clustered indexes I add to every table, and I might add non-clustered indexes for areas where I know joins required. But that's kind of where I stop. And then I wait till later to figure out what goes on. In other words, I don't try to guess ahead of time. I think an index is going to be useful because I may be wrong. It's better in a brand new application to have the clustered indexes appropriate, have your non-clustered indexes for the foreign key relationships, because you know you're going to need those for joins. But everything else, I will just wait and see what happens, and I'll run DTA. Because in a brand new app, maybe developed in-house, I might run DTA the first day. And I might see right away, obvious, we need some indexes. And then I might run it a couple more days later to see some more. And until some point, I'll get to the point where I'm happy with the indexes that I have in my system. Third-party vendors kind of the same way too, because oftentimes they come indexed inappropriately. So again, but again, if you find indexes that you don't need, you should get rid of them because it's being maintained. There's overhead associated with maintaining them, and why waste that overhead? Another one is duplicate indexes. I mentioned that briefly before, but SQL Server will allow you to create the same index over and over and over under different names. And it's hard to find out. I mean, to sit down and compare them by hand or by eye is time consuming. So a variety of people have written a bunch of scripts, and I've listed some of them here. Basically, if you don't want to write them all down, because you can download these slides eventually. This presentation will also be available on a video eventually. But in the meantime, you can, if you don't want to write all this stuff down, if you basically do a Google search for basically find duplicate index to SQL Server, you'll come up with these articles. And actually, I've used all these scripts. And they're all work slightly differently, but they all essentially do the same thing as they find redundant indexes. But guess what? Is a redundant index always bad? That's an interesting question. If you have, here's an example. Let's say we have an index on column A, and that's all it is. Now we have another index which is on column A, B, and C. So you think the first column A is redundant, right? Because both of them start with column A. So a query could use either one, correctly? So why might you want to keep both of them? Exactly. In certain situations, when the query runs, if it only needs column A, that's the only data it needs to retrieve and work with, rather than retrieving column A, B, and C. So just because it's redundant doesn't necessarily always mean it's bad. But unfortunately, it requires quite a bit of experience from the DBA to be able to evaluate that kind of thing. So when these kind of things run, it can evaluate that for you. All I can tell you they're redundant. Then you, as a DBA, have to figure out what's going on. Because sometimes what you find out is the indexes are exactly the same. So it's index A, B, C for columns A, B, C, D, E. And then there's another one called E, F, G, H for columns A, B, C, D again. They're obviously redundant and unnecessary. So you can delete those. But the ones that have the overlap, again, you have to kind of evaluate based on your experience as a DBA whether they're necessary or not, or useful. And you may have to experiment, get the queries out that hit them and run them and see what they do. See if the query, which index it uses. And if you notice that some queries used one and some used the other, and there's a difference in width, and you look at the I/O used by them, you may say, oh, I should have both of those, or maybe not. Again, that requires experience. But you should begin doing this regularly. This is, again, a very important one, fragmentation. I think everybody's probably familiar with the concept of index fragmentation. It's a very normal thing. Every index will become fragmented eventually over time. And it's a normal thing. We just have to accept the fact. So what we have to do is we have to come up with a method to regularly identifying fragmentation and removing fragmentation of our indexes. It's kind of a controversial topic somewhat, but one thing that's not controversial is that you have to do this. I see people who never run defragmentation on their indexes, and they get really fragmented, which really exacerbates any I/O problems, and again, which hurt performance in your systems. There are 3 ways to do defragmentation. Most of you are probably familiar with them: to reorganize and rebuild, both of which are available in standard enterprise editions. Reorganize is an online operation and won't affect your users. Rebuild is kind of a bad one because whenever it reorganizes a table, that table is locked for the entire time the reorganization occurs. So that's why it's considered an offline operation. Of course, again, if it's not too big a table, it only takes 2 or 3 seconds, it's not a big deal, people just wait. But if the table is 1 billion rows and you reorganize it, and it takes 4 hours to reorganize it, then it kind of causes a problem because the users can't access the data. So you have to do it off time. Or unless you have Enterprise Edition, there's an online version of Rebuild that you can use, which allow people to get into the system even though it's rebuilding. All these are fairly resource intensive. All these have their pros and cons. What's interesting is that for years, I've known what these commands have done. And there's lots of information in books online, there's lots of information on the internet about how to use these, when to use them, whatnot. Guess what? I did a research project. I decided I'm going to sit down and figure out exactly how these work. Do some experiments, empirical testing. And I did that for a presentation that I wrote. And guess what? I found all kinds of things I never knew before and that are actually wrong in many publications. Unfortunately, I have a whole presentation and I can't talk about it here, but I'll refer you to a couple things in terms of we can get more information. Now, on Books Online, you've probably seen, if you've gone and read about this, you've probably seen this kind of formula before about how they recommend you either rebuild or reorganize indexes, for example. If an index is less than 1,000 pages, of course, a page being 8K, don't even bother defragging it because it's too small to worry about. And then you see things like if fragmentation is less than 5%, again, ignore it. If it's between 5 and 30, you should reorganize. If it's more than 30, you should rebuild it. What's interesting about that is from Books Online, you see it all over the internet. Because the guy who wrote that information in Books Online was Paul Randall. And how many people here know who Paul Randall is? Many of you do. He actually wrote a lot of SQL Server back in 2005. He's quit since then, now he's a consultant. And Grant Fritchie, who's one of our speakers here today, a couple of years ago was in a session with Paul, and he asked Paul, where did you come up with that? His answer was, I just made it up. And people have been taking this for gospel for years because it's in Books Online. Books Online can't be wrong, right? And he explained, well, we didn't have any way of knowing it, and people were wanting some recommendations, so I just made them up. So they're better than nothing, but they're not the ideal solution. You'll have to probably come up with some kind of trial and error, ideally, because there's no way I know of coming up with a perfect solution for every need. But I do have my personal recommendations, which is on the next slide. First of all, if you have an option between rebuilding and reorganizing, always use rebuild. Rebuild is much superior for lots of reasons I don't have time to list. But there's a whole slew of reasons, the way they work differently, that rebuild is so much superior. So you have a choice. By choice, I mean you have a time frame where you can do it. You have a maintenance period because, again, that table is going to be offline. Whether it's 2 seconds because it's a small table or 4 hours because it's a long table, it's going to be offline during that time. Unless you have the Enterprise Edition where you can do the online version of rebuild, then you're okay. But if you have the choice, always choose rebuild. But you always don't have that choice, though. Now, if your database window is not very big, because you're 24/7, maybe you have an hour or two at night during a slow part of the day, you can do some stuff, then maybe some variation of the previous screen here might be okay. But I use a little different numbers. Rather than 1,000 pages, I use 100. And rather than using the 30%, I use 20% from the number. So in other words, I change it slightly based on my experience. But again, I prefer not to do that. But if I don't have any choice, I may do that. Another thing is, again, and this is something they didn't mention, and this is actually is true. If your fragmentation is less than 5%, it's probably not worth messing with. That's pretty legitimate based on my testing. Another thing too is you need to rebuild or reorganize, whichever one you can do, as often as you can, at least daily, because it accumulates. Right? I mean, if you don't do it today, it's going to get worse next day and worse next day and worse next day. So you need to constantly keep it up. So do as often as you can. I've seen people just do it once a week, and that's not a good thing because performance is great right after you do it, but then each day it degrades and degrades and degrades and degrades. And it also takes longer to run. Because if you do it every day, it's shorter because there's less work to do. If you wait once a week, it's a lot more work to do because a lot more fragmentation has occurred. So do as often as you can. Now, there's another weird case that comes up if you have a huge database with huge tables. Let's say you have a billion row table, and it takes 4, 5, 6, 8 hours to rebuild. What do you do? And even reorg, let's say, for example, might take 4, 5, 6, 7, 8 hours in the same table. What do you do? Because when these run, it takes resources. Even reorg, even though it's online, it still takes resources. If you have a server that's already really busy, how are you going to do it? Well, one option is, it's not a perfect option, but it's better than nothing, is to schedule a job to do a reorganize during some time of day when it's a little less busy, maybe run it for an hour. It's not going to be done in an hour, but it's better than doing nothing. So every hour, 1 hour a day, every day, for that little window, reorganize. Because it's something you can stop and start with no problem. Rebuild is different. When you start rebuilding a table, it has to finish. If you cancel it, it will roll it back. Reorganize, you can stop anytime you want to. So in huge situations, and again, it's not that common, but if you have huge databases, that will make a difference to you. So it's one way of kind of getting around the problem. It's never a perfect solution, but it's better than doing nothing at all. Another thing, too, I also recommend is instead of creating your own scripts to do all this kind of stuff, use someone else's script. The one I recommend is a gentleman in Sweden named Ola Hallgren, and that's his website. How many people are familiar with his scripts? A whole bunch of you? Good. And those scripts are very good scripts because he updates them constantly. He takes a lot of feedback. He takes it very seriously. It's a free product, and he's very proud of it. And it's a very good program. And it has lots of parameters that you can set to meet your particular needs. It works with all kinds of different backup products. Has all kinds of options in terms of what numbers you want to use. You just go, of course, it has the default ones you may take, but I go in there and tweak them myself. And I use that for all my servers, too. So I have a consistent script in all my servers. Of course, some people write their own, and that's fine, too. So just a couple things in terms of demoing. SQL Monitor has an alert for fragmented indexes. Too far. One of the alerts, let's go back to configuration and alert settings. And then we want to check out fragmentation. This is another alert that's built in, and you can set the parameters the way you want to. So if you have a situation where you're having problems with fragmentation and you want to be warned about it, you can. So it's just another tool that's available to you. It's also another tool that Redgate recently came out with that might be useful to you. It's called the SQL Index Manager, and I've already ran it here for this particular database. It will go through and analyze all your indexes and make recommendations. And this particular database, it's a real database, had 1,400 indexes in it, and it came up with about 40 recommendations. And it shows you how big the database is in terms of pages. That's what the red indicates, and the blue indicates how much fragmentation there is. Obviously, here we have a huge 147,000 pages. That's an awful big index, and it's 100% fragmented. So it's a kind of a graphical way of seeing what's going on. And this tool is kind of interesting in the sense that you can say fix indexes, and it will create a script, and you can or run it live, and go out there and fix what you need to be fixed. And it won't try to rebuild or organize stuff that doesn't need it. That's what a lot of people do. For example, if you use the SQL Server has the maintenance plan wizard, if you used that before, if you have, one of the things, I don't know if you noticed it, it has an option to reorganize and rebuild. Well, the option is, when you say rebuild, it will rebuild every index whether it needs it or not. It's so stupid because it has the ability to differentiate it. This can differentiate it for you, or you can write your own script to do it too, for that matter. But I wanted to kind of point that out. It's kind of handy to see that. So I'm doing fairly good in time here. Something also that's very important for you to do is maintain your statistics, which is actually goes hand in hand with indexing. I mean, I consider them things you do together as complements, always together. Now, by default, you may be aware of that in theory, SQL Server is supposed to automatically maintain your statistics for you, both your index statistics and column statistics. And in theory, it does do that for you under a very crude formula, which actually has been improved in 2012, but still it's not perfect. What often happens is that the statistics should be updated more often than they are. In other words, they get old, and because they're old, when the query goes to execute, the query optimizer has old statistics, and it will create a bad execution plan for you, and then provide bad performance. I don't like to rely on that. So besides that happening, it's going to happen anyway in the background, I like to manually update my statistics at least daily, if not more than daily. And I'll talk about that example in a moment. But at a minimum, if you use the reorganize option, when you run that, it will automatically, it will not automatically do anything with the statistics. In other words, if you have your index statistics and your column statistics will not be updated. So if you use reorganize, you'll have to run the update statistics command. I recommend using with the full scan option so it looks at all your data, and all means you both update column and index statistics. So once I've done, say, if I've chosen to use reorganize, then I will run this command immediately afterwards because the statistics are updated. On the other hand, if I use rebuild, it's a little different. When you rebuild, it will automatically update the index statistics for you, but it will not update the column statistics for you. So if I use rebuild, then I run this command, which basically says only update columns. I don't want to run this one because if I say all, it's going to basically do it twice. It's going to rebuild the statistics for the indexes once for the rebuild, and then why would I want to do it again? It would be kind of redundant. So here I only update the column statistics. It's important to do both of them. A lot of people aren't aware of this little feature or characteristic way SQL Server works. But it's important that both types of statistics are updated regularly. Now, have you ever seen an index where it works most of the time? And let's say it takes 2 seconds, arbitrarily, all the time, 2 seconds, 2 seconds, 2 seconds, and all of a sudden it's 30 seconds. And people start calling or whatever. Why is my query now taking 30 seconds? And then all of a sudden it's 2 seconds again. And then all of a sudden it's 30 seconds. Anybody experienced that kind of a situation? That's normally because of indexes. The statistics being outdated. So I've seen tables that the statistics, the data changes so often that the statistics can't keep up, and so they're virtually always out of date. So I've actually created jobs that once an hour will go in and go to a specific index that I know has a problem and runs that command on that index every hour, 24 hours a day. So it's always up to date. It's kind of a picayune problem, but it does happen. I've had that problem happen to me where my first goal is try to do it nightly, and that will solve most cases. But some of them, it's the nature of the data and the way it changes, and because statistics aren't updated appropriately or as quick as they could be because of the crude formula Microsoft uses, I go in there just manually do it, and it solves the problem. It's kind of crude, but sometimes you have to do crude things to solve problems because of holes in Microsoft or because of the unique nature of your application and the way it works. Another thing you need to do, this is people often ignore. How many people here have had a database that has some point become corrupted? Raise your hand. Okay, everybody who did not raise their hand will have to raise their hand eventually because you'll eventually have a corrupted database. It's going to happen to everybody. The question was, have you ever had a corrupted database? If you haven't now, you will eventually have one. It happens to everybody. And corruption usually occurs for one of two reasons. Again, hardware related, drive just fails, and that's going to happen eventually, or bad drivers are the main things, and that's happened to me before too. There's a few other things that could happen, but they're like less than 1% of the cause. 99% of the time it's hardware or bad drivers. Of course, what I do is to help minimize that is always be sure my drivers, my firmware and my hardware and the drivers in the OS are always updated and current. That's a good step. That'll help minimize some of the problems. And also, many of the high-end systems, like SANs, will have software that will monitor the quality of your drives and will let you know ahead of time if there's potential problems. And that's a good thing to do too, so that will minimize it. But even then, eventually, someday, you're going to have a corrupted database. And what's also worse is that sometimes databases get corrupted, but you don't know it, because the piece that was corrupted wasn't accessed that day. And maybe it's only accessed once a week. And sometimes the corruption can grow. And you can make a backup of a corrupted database, and so when you restore it, it's still corrupted. So it's important that you identify any corruption as soon as possible. That way, if you ever have to go back to a restore, you can have a minimum amount of data. For example, say you backed up every day. I mean, you keep 2 weeks of backups or a month of backups. But if the corruption started a month ago, you have a whole month of corrupted data, because often you never hit that table. Now you've hit that table, now you have a problem. Now you have to figure out what you're going to do with it. So it's important to run some kind of tool, which is again generally DBCC check DB, regularly, ideally daily, on all your databases. Now in a perfect world, what you should do is run this before you run your backup. Because why run a backup of a database that's corrupted, right? So that's kind of a theory that you can implement in some cases, but you can't always implement it all the time, and which I'll talk about in just a second. Because again, the goal is to find it as soon as possible. And before I jump into something else I want to mention here is that if you have a problem with corruption, people often will go into DBC, check DB in books online, and they'll see some options called autofix or other things like that. Never ever use those. We know what autofix really means. It means auto-delete the bad data and leave a hole in your database. So you virtually never want to do that. The only time you might have a situation where you're okay is if the corruption occurs in a non-clustered index, and you can just drop the non-clustered index and rebuild the clustered index. Then you're okay, once you identify that. But if it's in a clustered index where your data actually exists, and you have some pages that are now corrupt, and if there happen to be pages that have metadata in it, you're really goofed up. And you have all kinds of problems. And most likely, you'll have to go back to a previous backup. Sometimes you can fix it, but lots of times you can't. Depends upon the nature of your problem. So it's really important to catch that as soon as possible. And don't use the autofix stuff. Because, again, it just deletes your data. A lot of people don't realize that. It gets rid of your corruption, all right, but it also gets rid of your data, which is not a good thing. But DBCC check DB is very resource intensive when it runs. It's very I/O intensive, very CPU intensive. It uses tempdb a lot. It pounds your system. And it can take a long time to run in a large database. And because of that, people don't like to run it. Especially if you have a 24-hour, 7 shop, has to be up all the time, and you start running this thing, all of a sudden people start complaining because it locks tables and server performance goes way down. And so say, oh, well, let's don't run it. It's just too much trouble. Besides, our hardware is so good. We have a SAN, and we have RAID 10. No big deal. Well, none of that really counts. They still get corrupted. So you need to run DBCC check DB. So what I recommend is if you have a situation where you can't run it regularly because it takes a long time, or it's too resource intensive, you don't have a maintenance window, what you do is simply once you do your nightly backup, move it to another machine, restore it, and run DBCC check DB on the backup. That way you've now offloaded the work onto another machine and won't affect your production machine, and you're able to do this daily. Now that's a kind of a pain in the neck to do manually, but I'm going to show you a demo here shortly how you can do it automatically. But it's a big deal. You need to run it. I've seen people who only run it once a month. Or, even worse, I've only seen people who run it when they have a problem, which is actually too late. So you need to run it ahead of time because you want to catch the problem as soon as possible. So that way, if you have to go back to a backup, you will lose a minimum amount of data. That's the key thing. So a couple things I want to demo here. The first one, again, is in a SQL Monitor. There are 2 alerts that are useful for you to help you be sure that you're doing your preventing your corruption. Let's go look at those. I'm going to go back to the alert settings. And one of them is a fragmentation. Oh, that's what we just did. It is, there it is, right below it, integrity. So in other words, if integrity check has not been run, it will give you a warning, because you see defaults here are actually pretty nice. I would personally set the low as 1. In other words, if you didn't do it for 1 day, I'd want to know for some reason. For example, see you had a job and the job failed, then this will alert you that it wasn't done. So you know you need to go figure out why it wasn't done, find out why the job failed, and then run it. And another one, which is sort of related to what I'm talking about, I want to mention it because it is kind of important. Even if it's not directly related, but it's sort of related to this topic, is one called page verification. I think most of you know that every database has a page verification setting that can either be nothing, checksum, or turn page. You've all probably seen that. What this little alert does is if it finds any database that says nothing, that's a bad thing, because it's again, another page verification is another way to help find bad data besides DBCC check DB. And if you have nothing, that means it's not doing any work, and you don't want that. You want something turned on. What you need to be turned on is checksum. The torn page option is actually old and deprecated. It can be used, but it's not as efficient. So any database now today, if you look at it, should be set for checksum. Now when you look at it, it may be torn page. And you say, well, why is it torn page, not checksum? That's probably because it's an older database that was created maybe in the 7.0 era, 2000 era, and then was upgraded. When you upgrade a database, it doesn't change the setting for you. So when you upgrade a 7.0 or 2000 database to 2005 or 2008 or 2012, it will not manually make it checksum. You need to do that yourself. Just again, I don't know why Microsoft doesn't do it for you. There's no downside to doing it. It's all upside for doing it, but you need to do that. But this will tell you if it's just set for nothing is all. Now the other thing I want to show you, I think, let me see if my demo right. Oh, actually I'm going to save this demo for a little bit later. I'm going to mention it now and demo it later. As I mentioned before, is that one of the recommendations is if you can't run checkDB CC every day, because again, you don't have a time frame or it's too resource intensive, it's best to do it off onto another system. SQL Backup Pro has the ability now to do it for you automatically. But I'm going to wait and show you a demo of that just in a moment, because I actually want to do two demos in one. Because again, a lot of people don't do this because it's a pain in the neck to set up a manual job to go out there and restore a database or run DBCC check DB on it. But we can automate that for you. So we're getting close here towards the end. I want to talk a little bit about backups, and then I'm going to come to my last demo. On creating backups, I think most of you are probably aware of this. If you have a production server, you'll want to use the full recovery mode. And why is that? Point in time restorability, and of course, again, the ability to restore to right before you had your problem. Yeah, so you lose the least amount of data. Otherwise, if you do a full backup only once a day, no transaction log backups using single user mode, you can lose up to 24 hours of data, right? You don't want to do that. You want to do regular transaction logs. And the only way you can do that easily is using a full recovery model. And so I recommend that always in production servers. Obviously, you want to create some kind of job that does regular backups, you know, your full backup, differential if necessary, and transaction log backups regularly. I do transaction logs a minimum of once an hour. Sometimes I do them every 5 minutes, depends upon the system and the scenario. But you need to do that regularly. Also, when I back up, I always use the restore with verify option. That just helps me sort of see if the backup's good. It's not a perfect indication the backup's going to be perfect, but it's, again, one little step closer to be sure my backup's good. Because just because you do a backup doesn't mean it's good. And even if it passes this doesn't mean it's good. But it's a better chance because it can catch some early problems with backups. So I'll run that. Another key thing that you need to do, and this is I'm sure most of you don't do, I'm not going to even ask or raise the hands on this one because I don't want to embarrass you, is that the only way to know a backup is good is to restore it. Just because you make backups and lots of backups and you keep lots of backups doesn't mean any of them are any good. The only way you know is to restore it. So one thing I recommend is that you regularly restore your backups to test it. That's time consuming and boring. And there's something though we can automate. I'm going to show you the demo of that in just a moment. Another key thing, which I see a lot of people don't do a very good job of, is the backups that you do have, be sure that they're physically secure, and of course be sure they're encrypted. Because backups, if they're not encrypted, guess what happens when someone takes a copy of it? They can install it on any machine they want to. You hear that in the news occasionally where people will lose backups. And they had, banking information or social security card numbers or important stuff on it. And now all of a sudden they're gone, they don't know why. Well, it wasn't encrypted. So obviously encryption is really easy to do, especially with SQL Backup Pro. And because also need to be stored off-site. I used to work for an $8 billion company. And what they used to do with their backups is that they would, these put on tape, they'd have a guy stick them in this big cart. He'd go in the cart to a parking lot, all the way to a building next door, a whole 200 feet away, put them in a file cabinet with no lock, and that was the protection. And of course, if a tornado came through, both buildings would be taken out. And there was no security, they weren't encrypted or anything. And it was an $8 billion company. I thought it was unbelievable every time I saw that guy walk through every day with his cart of tapes. I just shook my head every time, just wondering when he was going to have a disaster. Fortunately, when I was there, they never did. But if they ever did, there'd be a big problem. Another issue, of course, you have with backups lots of times, and many of you are probably already familiar with this issue, of course, is space in terms of compression. Because backups can take a lot of space if you keep lots of backups. So obviously, backup compression, whichever form you use, will not only reduce the size of your backups, it will also reduce how long it takes to do the backups, which is a good thing. How many people are using some form of backup compression now? Many of you are good. Again, it's something that's very important to do. And again, I'm going to do here a real quick demo of SQL Backup Pro and show you basically this feature that would automatically do a restore for you and automatically DBCC check DB for you. It's just a really quick demo on that. This is automates a very boring feature. Okay, let me find. Oh, I guess I didn't bring it up. How many people here happen to use SQL Backup Pro? A number of you? Okay. So some of you are familiar. I don't want to go into a lot of details in this, but I want to show you a couple of the cool things. Let's say, for example, I have this database here, index dfrag, and I want to do a backup of it. And I'm going to create a backup job. And obviously, since I have only my test machine at the backup, same machine locally, I wouldn't normally do that, but I'm going to back up from my machine. I'm going to back up a single database. I have obviously options for full, differential, transaction log, copy-only backup. So I'm going to go ahead and do a full. And I have to create a schedule. I'm going to keep that real simple. This is stuff that you've all seen before. The cool stuff I want to show you here is in just a moment. And this is just where you want to store it. But this is the one I want to point out. This is a nice thing about SQL Backup Pro, is that once it makes a backup, wherever you want to, usually locally or on a SAN or whatever, it has the ability, when this is done, to take that copy and copy it over the network automatically to some other location, like a machine where you test restores. So keep that in mind. So you set up a backup as a normal backup, but we'll move it to another machine that's designated just for the purpose of doing restores. It'll create a job and do this all for you automatically. And then the other nice thing about it, of course, is the compression. We have 4 levels of compression. The native compression coming with SQL Server only has 1. Also, you have encryption. That's not available in native compression either. So, but again, that's another thing I highly recommend that you do. I'm not going to go through all the options because they're not all that critical. Here's again, checksum and verify. 2 other options help verify that your backups are good. I always recommend that you do those. And you can go next, and then it will create a script for you and create a job for you, and you can run it. So when it does the backups based on your description, key thing I want to point out is that we'll now move it to another machine. Now once that's over there, what we want to do is we want to restore it, and then we want to run DBCC check DB on it to see that it actually is good. 2 ways. It will actually will actually restore as we want it to, and it actually is consistent because DBCC check DB will say it will. So what I can do now is once I've created a job, it will create what's called a reminder. It's basically a reminder is to create a schedule a restore job. So I can click that one, and it will come up and pre-populate itself and say, I want to take this database called AdventureWorks, and I want to restore it to another machine. So I click on it, and then I can specify a different name for it. In this case, EventureWorks verification, and username you want to. This shows you where you want to move it to. Pretty simple stuff. But then it will also run DBC check DB. You can choose all the options for this. So a whole bunch of options available for it. And usually I just check the default and click on next. I want to leave the database operational, next, schedule it, and basically I'm done. I don't want to go through all the screens. But the key point I want to get across is I can automate jobs to do my backups, then take one of the backups, copy it to another machine, and then the job will schedule, they'll take that backup, restore it. If it's okay, great. If it's not okay, it will email you saying the restore is bad. Or if it restores good and runs DBC check DB and it's good, nothing can happen, or you can be notified. Or if it's bad, it will email you as bad, and you can go look at the error messages it created to find out what's going wrong. So it automates all that for you. You don't have to do it yourself, which is really cool. Yes, sir?
Right. What's the best, from a vendor point of view, licensing model for, presumably, if you're restoring on a separate machine, you need to buy the software again?
In terms of SQL Backup Pro, I asked one of the people out front who sell it. I don't know much about licensing. They're the ones who can help you out on that. So again, my session, some reason people are leaving, the session is actually done. The 30-minute break starting, so I'm running a little over here. So if you want to leave, that's fine. I just got a few more slides and I'll be done. Just did that demo. One last thing about maintenance jobs. I want to mention some of this should be obvious, but maybe not. I like to keep my maintenance plans from system to system the same, or as much as I can, because it makes life a whole lot easier if they're all the same rather than completely different. And that's why I like to use like third-party scripts to do that for me. Again, don't duplicate maintenance tasks. I've seen people, again, and I mentioned this earlier, that they will rebuild their index. Then they will update the statistics for the indexes right afterwards, which is redundant because it's already been done before. So in other words, don't do duplicate tasks. Obviously, schedule your jobs so they don't overlap. I've seen many people who just go and set the default time, which is usually midnight, and run all the jobs at midnight. So they do all the backups at midnight. They do all their reorgs or rebuilds at midnight. They will do everything at one time, which obviously will overwhelm your machine. So obviously, you need to scatter them over the time so they don't overlap each other. Yeah, obviously, you have to figure that out yourself. It won't do it for you automatically. Obviously, you schedule your tasks during slow times of day. I think most of you know that. But again, you also need to monitor your jobs to be sure that they're working correctly. And there's actually a feature in SQL Monitor that will do that for you. Let's go back to alert settings. For example, if you have a job that is failed, you can be alerted on that, which is kind of nice. But another more interesting one is if the job takes longer than usual. I think this is the right one. That's long-running queries. It's kind of hard to read in a small screen because it's not all the way out. It's long-running. There it is. Oh, wrong one again. Oh, there it is. Yeah, there. Job duration than usual. This is kind of an interesting one because most of the time when a job runs, it runs a typical an average amount of time, So what the software does, it looks over the last 10 runs and averages it, and if the next run deviates substantially from a normal run, it will warn you. For example, you've probably had this happen before where, and I know it's happened to me in the morning, I'll go into the office and all my jobs should have been done, but I see, jobs are still running for some reason because something got blocked or whatever. And then what this will do is allow you to be alerted, an email sent to you that, a job's running unusually long for some reason. And you need to go figure out why it's running long and then either kill it or find out what's blocking and stop the blocking, that kind of thing. Which is another kind of interesting feature to make you more proactive and be sure that your jobs are effective and run the way they should. So that's kind of a cool little feature. Okay, I just demoed that. So to summarize, database maintenance, very critical, very boring, but very, very important because it affects not only the performance, but the availability of your servers. And by availability, I mean, I've seen a couple cases where the fragmentation was so bad on the server will not come up. So it can affect availability, not only performance. Another thing is do is of these kinds of tasks is try to automate as much as you can. Because in the old days, I used to do this all by hand. But now there are tools available, some tools that we have, scripts that you can write. We can almost automate all this stuff for you. So you don't have to go in and spend a lot of time looking at this stuff physically. You can actually have scripts to do a lot for you and send you emails when issues occur. What I want you to do, hopefully, is next week, when you think about it, evaluate how your current maintenance plans are working on your current servers. In other words, all the things I talked about today, which are big things, big topics, go back and see if you're actually doing all this stuff. Are you manually managing your MDS and LDS correctly? Do you have the proper and appropriate index defragmentation? Are you going through and evaluating the indexes regularly? Are your jobs overlapping? Those kinds of things. Do you have alerts set up to know if your jobs have failed? So evaluate your system, look at it. You may be surprised to say, oh, I'm missing something here really important. And I need to change that right away before I have a problem. So I'm sure there's at least one thing here today I've talked about that will apply to probably pretty much every one of you in the audience. So think about doing that when you get back. So I'm out of time. If you have any questions, I'll be here and answer them. Otherwise, you go ahead and take a break. Thank you for coming.